Okay, so happy Friday. I hope everything went well with Law of Sines yesterday. Remember, when I come back on Monday, I will be happy to answer any questions that you've had on both of these sections. Hopefully, it won't be too terrible. If you need to help each other out in terms of answering questions and whatnot, please do so. So today we're going to look at law of cosines. So like I said, it's not really hard to pick out which one you need law of cosines for and which one you need law of sines for, because if you don't have an angle in its opposite side, you can't do law of sines. Pretty straightforward with that. So law of cosines is a little bit more in depth. A couple of the first problems that we're going to do, if you can plug it in the calculator, then you can get the answer right, kind of thing. But then afterwards, it takes a little bit of algebra to solve the rest of those. Okay, so law of cosines is this massive formula here. Go ahead and write that down. Again, it doesn't matter where you put A, B, and C, but it does matter where you put its opposing side. This formula can be manipulated. And what I mean by that is that not manipulated, but used different ways in terms of if we have A squared over here, notice how we have the angle A, and then we have B and C, okay? So then what I can do is if I want to make this B squared, that means the other two angles other two sides that are not being used are A and C. And then I would do cosine of angle B. Same thing if I did C squared. The other two angles that aren't being used are A and B. And I would find cosine of C. Okay. But they might only give you one of the formulas, but they all mean the same thing. Okay. All right, so let's look at this problem first. Okay. So naturally, from learning yesterday's lesson, I see an angle and its opposite side. But I don't see another angle and an opposite side that allows me to do law of sines here. Okay. What I do see is an angle in between two sides. Okay. So if I'm looking for A, I have A squared. That means the two sides that are not being used is the 2.5 and 3.5. And then I'm going to do cosine of the angle of the opposite side of the side I'm looking at, so 40 degrees. So in this particular case, this one's nice because we can just plug it in as is. So if I plug in that entire right side, again, please make sure that your calculator is in degree mode. I'm going to keep what's in my calculator, but I'm just going to round to show you where I'm at. And then to get A completely by itself, I'm going to do the square root. But I can just do square root of my answer, remember, which is second negative sign. And A is going to be, and they did one decimal place, so I'm going to do 2.3. It was 2.257, so on. Okay? So that would be my A value. So like I said, the first couple of problems we're going to do, you're just plugging in that entire right side, basically. Okay? And then take the square root of it. If you're bold enough, you can, and not make too many mistakes, you can go ahead and plug in all of it under one big radical if you wanted to. That's a point in there. And then cosine of 40, of course. Okay. All right, go ahead and pause this one and try this one on your own. We're going to keep going. So this particular one, I went ahead and did the square root at the same time as plugging in the right side, and I did 2 decimal places, even though the sides were whole numbers. If they were whole numbers, I'd probably use 6. So like I said, these are very straightforward. Plugging them in, done. Just don't mess up the numbers you're plugging in. Okay, so this is where algebra comes in a little bit more to play. We have all sides, and we need to solve for an angle, which eventually we're going to do the inverse of from what we learned yesterday. So let's go ahead and set this up. If I'm interested in C, 12 needs to be on the outside of the equal sign. So let's fill in the rest. Okay. So it's not one of those situations where I can just do all of the operations and then do the inverse all in one swoop. Okay. So I would take this one step at a time. I'm going to walk you through how I would do it. And then from there, you can kind of decide, hey, I found a different way to do it and I still got the same answer. You can approach it that way. So of course we have our 144. I know that I can combine these two together, but I cannot combine these with it because it is attached to this cosine of C. So I'm going to do that 5 squared and 8 squared together. And then I'm going to go ahead and do the 2, 5, and 8 together. Okay, I cannot do 89 minus 80 because that 80 is attached to the cosine of C. So I'm first going to get rid of 89. Don't forget that negative stays in front. Then I'm going to get rid of the negative 80. So from there, to do the inverse of cosine, I'm just going to leave that as a fraction just because I know that I haven't messed that up yet. And I can just simply plug that in. Again, double check and make sure your calculator is still in degree mode. And we are looking at 133.4 degrees. Okay, so a little bit more algebra is involved when you are having to solve for an angle. You can't just plug and chug like we did the first 2 problems. Okay, we have to take it in pieces. We have to realize what can be combined and what can't be combined, and then go from there one step at a time. The good news is, I know yesterday I paused to see if the ambiguous case was going to exist in our law of sines. We don't have to worry about that with law of cosines, so that's nice. Okay. Again, they could turn around with this particular problem and say, hey, go ahead and solve the whole triangle. So if that was the case, then the good news is if this is 133.4 degrees, I now have an angle and its opposite side. So then I can do law of sines. And then from there, I can figure out another angle. And then once I figure out the other angle, I just take those 180 minus those, and I get my final missing angle. Okay? So they could put it in words like this, and this is actually setting you up for how it's supposed to be done. You're always going to start with law of cosines if you are given all sides. So this last problem, I asked you to tell me what this side or this angle was. But if I didn't tell you that I wanted you to find angle C and I just gave you 5, 8, and 12, you're going to always start with that side 12. You're always going to start with the largest side. Okay. So this particular one, they're saying the same thing. Find the angle opposite from the largest side. So the largest side is going to be 15. So 15 squared. And go ahead, once this is set up, pause it and see if you can get the same answer as myself. I'm just going to call it A just to call it something. Probably should call it C just because usually C is our longest side. Maybe we'll switch to that just because we're used to that in the Pythagorean theorem and stuff like that. All right, now go ahead and pause it and go ahead and finish this one out. All right, so if you've watched this all the way through, then again, we take it piece by piece, and then we end up taking the inverse cosine, and we should end up with a side of 75, or an angle, sorry, of 75.3 degrees, okay? Again, feel free to message me if you have any questions. All right, let's check this one out. So we're gonna set up our triangle. I'm a visual person, so I need it to be where I can see it. Okay. And they want to know what angle B is. So I know that its opposing side is at 6.2. So I'm going to go ahead and put in the 6.2. Sorry, just wanted to make sure I did something on that last one. Oh, and here I go. I made a little mistake here because I'm so used to doing law of cosines. Check this out. So, which we're still going to use that. Let's look at what's going on here. I'm so interested in angle B that I realized once I was trying to set this up, I didn't know what A is. Okay. So for me, I could keep going, but then I would have to solve for two variables. It's not what I'm interested in. So then now I really have to look at what I do have available. So it looks like to me that I'm going to have to actually solve for angle or side A first. And then from there, I can solve for everything else. So if I have A squared, then I can use the other two sides because that's what I'm given. These are nice. Get to plug them straight in. And they only did one decimal place, so I'm going to stick with that. So since I was now able to find the side that I'm looking at, then now I can really look at it and say, well, hey, now I have an angle and its opposite side. I can do law of sines to figure out what my angle B is. So I'm going to do exactly that. So sine of 45 over 5.6 is equal to sine of B over 6.2. Cross multiply and continue it out. Again, go ahead and pause to finish the rest of this problem. not sure what happened there. These can get very tricky, only because it can become an issue with the fact that you're doing not only sine at or cosine at the beginning, but sine at the end. So you just really need to make sure you're paying attention to if you're plugging in sine or cosine. That gets a little tricky sometimes, and if you press one, not the other, then you're going to get a different answer. So please, please, please make sure that you are paying attention to sine versus cosine as well. Okay. Let's go ahead and try this one. Okay, and you should end up with angle T being 30.7. So the good news is that if I did ask you to solve the rest of the triangle, you would just simply do 180, and then depending on how many decimal places, if I asked you to go ahead and round, let's say we did 31, and that 126, then our missing angle is 23. So when you solve an entire triangle, it's all the angles and all the sides are evaluated. Okay. Again, feel free to message me if you have any questions from the past 2 days since I've been out. I'll be happy to answer them as soon as I can. You can send me a remind. You can send me a remind or an email or anything of that nature. And like I said, I'll get to it as soon as I can. And hopefully it wasn't too bad for y'all this week. I hope y'all have a good weekend. And we'll continue on learning more trig when we come back on Monday. We're getting closer and closer and closer to that Thanksgiving break, which means we're getting closer and closer to the end. So again, let me know if you have any questions. If not, have a good weekend.